Alright, so you're given a parabola. Okay, this is the original what you're given. Now they want you to transform it 3 different ways. A, they want you to place a red parabola on the same grid that shows the transformation. So the transformation is going to do this. It's going to take the original and it is going to do something in the parentheses. So that means it's going to slide it left and right. And it's going to do this. It's going to put a negative out in front. So if you have a negative out in front, that flips the orientation. So here's what we're going to do. This is going to slide it 3 times to the right. So it's going to take the vertex and it's go 1, 2, 3 to the right. And then the negative out front is going to flip it so it's oriented this way. And that is where A should end up. B, they want you to place a blue parabola that shows this transformation. Okay, this transformation happened outside the parentheses, so that's your vertical shift, that's up and down. So they're going to copy and paste it 3 units up vertically. So start here 0, 0, and just go up 1, 2, 3. So B should end up like that. And then C, place a green parabola. Okay, this one has 2 transformations. It has something in the parentheses and it has something outside the parentheses. So something in the parentheses, that's going to slide it left and right, and outside the parentheses goes up and down. So this is going to go 3 units to the left, 1, 2, 3, and 1 unit down, and it should end up right there. So those are the 3 different transformations. Now, next one is a multiple choice, and we don't know what family this graph belongs to. We haven't done anything with this kind of a graph, but that's okay. Transformations act the same on every family. So here's the original. So the original passes through 0, 0. This one, the new one, on the left, all they did was translate it translate it to the left a couple times. So they just copied and pasted. They slid it left. Now they slid it left k times, which is, who knows, if they're counting by ones, 1, 2, 3, 4, k would be 2, but we don't know what they're counting by. Maybe they're counting by 5s, 5, 10, 15, 20. So the number really is irrelevant. They slid it to the left k times. So which one of these tells you to slide that sucker to the left k times? And it is C. C tells you to slide to the left k times. Okay, this guy, you got a quadratic x squared minus 7x plus 10. There are terms, there are factors, there are coefficients. Terms are pretty easy. There are 3 terms. X squared is a term, so kill that. The terms are the pieces. So you got a quadratic term, you got a linear term. So you got a negative 7x to the 1, negative 7x, that's a term. And then you've got a constant. 10 is a term. 10 is just how many ones you've got. So you got 10 ones. So those are the terms. Coefficients are how many quadratics you have. So the coefficient would be this. You've got 1 quadratic. How many linear pieces you've got? You got negative 7 linear terms, and that's it. So 10 is not a coefficient. 10 is 10 ones, and that is called a constant. And that's not in any of the columns, so we're not going to worry about the 10. So you only have 2 coefficients, 1 quadratic and negative 7 linear. Okay, now factor. The factors, we can put something in the factor column. This will factor. You can change this to a times problem. If you change this to a times problem, there are numbers that exist that will times and give you 10 and add and give you negative 7. So we're going to go x, x. Those numbers are 5 and 2. And it's got to be a minus 5 and a minus 2. because that will times and give you a positive 10, but they will add and give you negative 7. So your factors, there are two factors. That quantity is a factor, and that quantity is a factor. So x minus 5 is a factor, and x minus 2 is a factor. So the only ones we did not use are x plus 2 and x plus 5, and that's okay. They don't go anywhere, so just leave them there. Now, you're given a quadratic. Find the roots. And we're in business because everything is on the same side. And on the other side, you just got 0. So, we got p squared minus p minus 30. So factor it. If you can factor it, you can find the roots pretty quick. And there are numbers that will times and give you 30, add and give you 1. P, 6 and 5. So one of them is negative, and it's got to be the 6. Because if you do a negative 6 times 5, that's a negative 30, but a negative 6 plus 5 is a negative 1. So that means your roots, your zeros, are going to be, you're going to let p equal a 6, and you're going to let p equal a minus 5. So these are your two roots. So if you let p equal a 6, it will give you a 0. And if you let p equal a negative 5, it will give you a 0. So that means you're going to have over here 1, 2, 3, 4, 5, 6, 0. There's a root, and you're going to have 1, 2, 3, 4, 5. There's your two roots right there. Now, we got to find the vertex. Use your roots to find the vertex. Your vertex is going to be centered between your roots. So halfway between the roots is going to be a vertex. So I'm going to count the spaces from this root to this root. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 units between these dots. So I'm going to do 11 cut in half, and that should be 5.5. So I'm going to go 1, 2, 3, 4, 5.5. Check it. 1, 2, 3, 4, 5.5. Okay, that's it. That means your vertex is going to land somewhere on this line. We don't know where. Okay, now to get to that line, if you start at 0, all you do is go over a half. So 0.5. So you're going to take 0.5 and you're going to either plug it into that p and that p and do the math, or you can plug it into this. We had p minus 6 times p plus 5. So I'll take it and plug it in there, and I'll plug it in there. So if you do 0.5 plus 5, that is 5.5. And if you do 0.5 minus 6, that's a minus 5.5. Now I'm going to calculator. Times those two together. Negative 5.5 times 5.5. And if you times these together, you get a negative 30.25. So now what that means is this. If you go over 0.5, you're going to go down 30.25, and that will be your vertex. So go over 0.5, down 30.25. So it's clear down here, way off the grid. So your parabola, something like that. So find the roots. Your vertex is going to go halfway between them, and then take whatever that is and plug it in, and it will give you the y. Whoa. Where are we? Okay, this guy right here. Now you're given a parabola, and you're in luck because there is the vertex, and that vertex happens to land on an intersection. So to get to that vertex, I just go left 3 and up 5. So you know that one. you don't know this equation for axis of symmetry. I don't know if we've ever talked about it, so it's probably not going to be on the test, but it's pretty easy. So your line of symmetry, every parabola has a line of symmetry. It is the line that cuts this parabola right in half. So that is the line. You can fold it always right over the vertex. So this line, the equation, because it goes through the x number line, it is x equals -3. Okay, your y-intercept, you should know your y-intercept. This parabola intercepts the y number line right there. So the y-intercept looks like a -4. We haven't talked about this either. So these two we haven't really talked about. Max or min? This is a max. It is a max. So it's talking about your vertex. Your vertex happens to be at the very highest point on the parabola. So the very highest point going vertical up and down, that is the max. So the min of this parabola, so the max would be, the highest it goes is 5. The min, the lowest it goes, would be probably to -infinity. So if you had a parabola that looked like this, that was right side up, the vertex would be somewhere like there. That vertex would be known as a min, because it is the lowest point on the parabola. Okay, the roots we know, the roots are there and there, and your roots don't land on intersections, so you just do your best guess, an approximation. So approximately, let's do this one. This one's between a -5 and a -6, so maybe like -5.25. And this one is between 0 and a -1, so it's maybe -0.75. So your roots are something like this. So that's just a guess, an estimation. Okay, now this is the best problem on the whole test. Here we go. You are given 3 equations. You got to find the roots. You're given 3 methods, but you can only use, and you must use each method once. So here we go. Move number 1. Get everything together on the same side. So I'm going to -5x. So the first one, you should have 3x squared minus 3x plus 1 is 0. The middle one, you got to move 2 terms over, so you got a plus 9b plus 9b. Then you got a plus the 2b squared plus the 2b squared. So the middle one, after you move everything over, you should have b squared minus 10b minus 33 is 0. And then the last one, you gotta move 3 things over. I'm gonna plus 2b squared to this. I'm gonna plus 2 1s to these -23 ones, and I'm gonna plus 8 b's to these b's. And after you do all that, you should have b squared minus 4b minus 21. Okay. Now, factoring is the easiest. Factoring, I want to factor 1. So look right here. You've got a equals 3, b equals -3, c equals 1. This one I got a equals 1, b equals -10, c equals -33. And this one I got a equals 1, b equals -4, and c equals -21. So I want to factor one of the ones where a equals 1. So the middle one or the bottom one. And you should ask, can you times and get 33, add and get 10? No. Can you times and get 21, add and get 4? Yes. So this is the one we're going to factor. We are going to factor b squared minus 4b minus 21. Because the numbers that times and give you a negative 21 and add and give you 4 are 3 and 7. And one of them's got to be negative, so the 7 is negative, the 3 is positive. And then if you factor it, the roots are going to be, b has got to be equal to a negative 3 and a positive 7. Those would be the roots. Okay, so the bottom one, that matched up with factoring. So I got 2 methods left, I got 2 equations left. Completing the square is going to go with the middle one. So the middle one, you can almost factor it. It's completing the square. If I got b squared minus 10b, it's the 33 that's screwing us up. So that's a 10b. So I'm going to minus the 30, or I'm just going to scoot it over, 33. Okay, now, completing the square and factoring, use the ones where a is 1, a is 1, because now look at this, a is 3, b is negative 3, this one, if this starts to get way tough to factor, so anytime your a is not 1, quadratic formula, and you're going to get to the point where you're going to do quadratic formula on everything, no matter what it is, you're going to get fast at it. So the quadratic formula is the best, because it'll do all types. Factoring will only work if your solutions are integers. Completing the square will give us some funky solutions. So here we go. I don't want a 33. I wanted a 25. So you take the middle, you cut it in half. 10 is 5 plus 5. So 5 times 5, I want a 25. So add a 0. If you add 25, the next second you got to take it away. Now these two play together. Minus 25 and minus 33. And that is a minus 58. And then these 3, that is a perfect square, which is what you created. That will be b minus 5 times b minus 5. So it's b minus 5 squared. Now solve for b. So undo the minus 58. Let's plus 58, plus 58. So we've got b minus 5 squared equals 58. Now we just got to undo the square. So we're going to square root. And anytime you do a square root, you got to give both roots. So it's going to be plus or minus square root 58. And then on the left, you just got b minus 5. Okay, 58 is a big number. Inside 58, if you try and pull some squares out, 58 is 2, which is done, and 29, which is prime. So there's nothing in 58. 58's cleaned up. So that means all you got to do is get rid of the minus 5. So let's plus 5. And let's plus 5 to this side. Now, the 5, these are 5 ones. And this is 1 square root of 58. So these guys are not like terms. You cannot add 1s with square roots of 58. So your final answer is 5 plus or minus square root of 58. So that leaves the last one for the quadratic formula. So we already got ABC. So here we go. ABC. X equals negative b, and b happens to be a negative, so there should be 2 negatives. Plus or minus the square root of b squared. Whatever b is, put it in parentheses. So b is negative, put it in parentheses, squared, minus 4 times a times c, all over 2 times a Okay, now it's just kind of calculator. So let's clean it up. Minus minus 3, that's just a 3. Plus or minus. Okay, this square root. Do calculator. Negative 3 times negative 3. Minus 4. Times 3 times 1. Enter. Okay, under the square root should be, I think it cleans up to be a minus 3. And then on the bottom, you got 6. And you can never have square root of a negative. That's a big deal. Square root of a negative. Take that negative out. That's imaginary. So here we go. You're going to have 3 plus or minus imaginary square root 3 over 6. And that is it. That is your solution, because you can't add reals and imaginaries. You're dividing them both by 6, so really you're doing like 3 divided by 6 plus or minus imaginary square roots of 3 divided by 6. And this will clean up. That will give you 1/2, but this does not clean up. So you either leave it right there as it is, or you can clean up this to be 1/2 plus or minus an imaginary square root of 3 divided by 6. Either one of these two is fine. And that is it.